Okay, so Pythagoras theorem. So the first concept in Pythagoras theorem is about a Pythagorean triplet. Before starting with Pythagorean triplet, the Pythagoras theorem, which you have studied so many times, we'll just revise that. So Pythagoras theorem says, in simple words, in a right angle triangle, square of the hypotenuse is equal to the sum of the squares of the remaining two sides. Okay, so if you have a right angle triangle, so this is ABC, and square of the hypotenuse, that is AC square, will be AB square plus BC square. Okay, now what is Pythagorean triplet? Any number that satisfy the theorem or that satisfies this equation, any pair of three numbers, okay, any pair, set of three numbers that satisfy this equation is called as a Pythagorean triplet. For example, take a very simple example, 3, 4, and 5. Okay, this is a Pythagorean triplet. Why? Because if you see, 5 square will be equal to 3 square plus 4 square. You can check. 5 square is 25 and 3 square is 9. 3 square is 9.
4 square is 16.
Yes, and 4 square is 16. And if you add 9 plus 16, you will get 25. So this equation is satisfied.
So, but if I add a 25 and 16, I should get 9.
Yeah. So there is a rule for that. There is a rule to check for whether it is a Pythagorean triplet or not.
The biggest one.
Yeah, the square of the biggest number should be equal to the sum of square of the other two smaller numbers. Okay, that is a rule which you have to use to check whether a given set of three numbers is a Pythagorean triplet or not. Square of the larger number should be equal to the sum of the square of the other two numbers. If it is, then you say it is a Pythagorean triplet. If it is not, you say it is not a Pythagorean triplet. So let's see some example. Practice set 2.1. First one. You have to identify which of the following are Pythagorean triplets. So first one we already checked, 3, 5, 4. You know this is a Pythagorean triplet. You can write it directly. 5 square is equal to 3 square plus 4 square. Therefore, you can say 3, 5, 4 is a Pythagorean triplet.
You don't have to solve and show.
No, no need. Okay, second one, if you see it is 4, 9, 12. Okay, 4, 9, 12. This will check. So 12 square is 144. 9 square is 81. And 4 square is 16. Check 9 square plus 4 square. What are you getting? This is 81 plus 16. So it is 7 and 97, which is not equal to 12 square.
Because 12 square is 144.
Yes, so you can say that 4, 9, and 12 is not a Pythagorean triplet. Okay, so the first sum also you can write it like this. The first sum actually we had done it before, no? That's why I did not write it. Here what you can do, you can show 3 square is 9, 5 square is 25, and 4 square is 16. So you can say 3 square plus 4 square is 9 plus 16, which is 25, which is 5 square. So you can say that 3, 5, 4 is a Pythagorean triplet. Is this clear, both the sums?
Yes.
Write it down.
I should write it there only, or I should write it in the text in the notebook?
Write in the notebook.
Okay. So if some comes for like half a mark.
One more. For fill in the blanks, they do come.
Okay. Done.
Can you check for the third one?
Yeah. Done. It is a Pythagorean triplet because 25 plus 144 equals to 169.
Show me how you have done it.
Wait 1 second. Oh, wait, 8 minutes. Just give me 1 minute.
Yeah.
Can you see it?
Yeah. Okay, perfect. Fourth one, check for the fourth one also.
I know that the sixth one is because last year we had this one in some sum.
Hmm.
So I remember.
Yeah.
But I'll see for the fourth.
Yes. Getting it now? Yes.
Yeah, just 1 minute.
Okay.
Hello?
Yes.
Yeah, the fourth one is a Pythagorean triplet.
Okay. Fifth and sixth one, will you do it for homework? Will you check it for homework?
Okay.
Okay. So we will
But
do.
what was the
Say.
earlier homework? Earlier no homework. No, I did all
No,
of that. Huh?
no, there was problem set 1. Problem set
What?
1. Sums, you have to do it again.
How many sums are there?
There are 6. I think 10 sums are there.
But all of them are cancelled, right? Oh,
No.
okay, that. Okay.
Problem
Yeah.
set 1, similarity.
Yeah, got it.
Okay. So we'll do this next Pythagoras theorem. Okay. The proof of the theorem we will do. Now, before that Pythagoras theorem proof, we need to know one small theorem or one small property. Tell you what this property says. Okay. So in a right angle triangle, if the altitude is drawn to the hypotenuse. So if you see, this is a right angle triangle and the altitude, that is this BD is called as altitude. Altitude means it's a perpendicular with perpendicular line drawn from B to the hypotenuse. Okay, so BD is the altitude. So if you see, because of this altitude, 3 triangles are formed. If first is triangle ABC, that is the main triangle, the bigger one. First is, this is the main triangle, the bigger one. And because of the altitude, this one triangle is formed here. That is triangle ADB. And this, another triangle below one, that is this one, BDC. Triangle BDC. Now, what this theorem says, this theorem says that all these 3 triangles will be similar to each other. Okay, triangle ABC will be similar to triangle ADB, and this will be similar to triangle BDC. Okay, this is what this theorem says. Is it clear?
But how will they be similar? One will be of 45, right?
No. Why
This
40?
will be of 45 and this will be of 45.
Hmm.
How is it equal? Oh, okay, here it is equal.
90 degrees forming there.
Oh,
It's not
okay.
equal and not equal, similar. Use the word similar. Because when you say equal, that means the lengths should be the same. But that is not the case. Lengths are different. Okay. So make a note of this, write it in your notebook, write the statement, write this, draw this diagram and write this. ABC similar to ADB, similar to BDC. That means this one similar to this and that similar to your original triangle. Write it down.
Hello?
Yeah,
Done.
done. Okay. Now let's do the theorem on geometric mean. We'll
By
not
the
do
way, why do I have to write these theorems in the book when it is there in the...
statements can come for exam. That's why I'm making you to write.
You took only half of the theorem.
No, proof
Here,
we are
which
not.
the hypotenuse... No, no, no. Which the
Okay.
hypotenuse is divided, you did not take. But I've just take... Oh, God.
Okay. Theorem of geometric mean, what this says now. Okay. In a right-angled triangle, if you draw perpendicular to the hypotenuse, that is this altitude, then what happens is that this the distance of this QS will be under root of RS into SR. Okay, so distance of the altitude will be RS into SR. That's it in this geometric mean theorem. Is this clear? Did you understand this?
You said it so fast, I did not... This space QS... Okay, fine, got it. So not QS ka square root, only the
Yeah.
length of... Okay, fine, got it.
This is also
RS and SP, right?
SP. Yeah. Sorry.
RS and SP, QS.
SP. Okay, this sometimes is also written as SR QS square is equal to RS into SP. But both mean the same.
How did they do that?
Square. See, when you take the square, this side becomes square root only, so QS is equal to square root of this.
Oh, okay. Oh, it's
So,
like that.
So it's just a way of writing it. But remember the first formula only.
Yeah.
Okay. So we can do the now. Next, a second sum of a practice at 2.1 we can do because it is based on geometric mean theorem.
Yeah. Are you telling me to unmute?
No.
Because I got a message that the host wants you to unmute.
No, I did not.
So I unmuted.
It's okay.
Okay.
You can stay on. Okay. Now here in this figure, angle MNP is 90 degree and NQ is perpendicular to the hypotenuse. This is given to you. Length of MQ, that is this, is given 9 and QP is given 4. You have to find out what is the length of NQ. So obviously, since it is given, angle MNP is 90 degree. This is given to you. And also it is given segment NQ is perpendicular to segment MP. Okay, this is also given. NQ is perpendicular to NP. So we will use geometric mean. So you have to write by geometric mean theorem. By geometric mean, we get QN will be under root of MQ.
3 plus 2.
Not plus, multiplication. Into QP. So that will be root of 9 into root of 4, which you can separate the root 9 into root 4. That is 3
Which is
multiplied.
3 into 2.
That is 6. So length of Qn equals 6. Is this clear?
6 centimeter, right? No, that is not given.
That's not given. So you write it just 6 only. Write it down.
What time are you ending this class?
Let's see how much we finish.
So I have a class at 5:15. Today is a Thursday, right?
Yeah.
Today is Thursday is the 9th September. Yeah, so I have it at 5:15, but I'll confirm. I don't really know if I have it or not.
Okay. I think this Pythagoras theorem, we have three exercises only. No?
Today is 9, right?
Yeah.
And I have only algebra, science 1, science 2, and geometry papers left.
Hmm.
Rest all papers I've given. So only yours and Renuka history papers I've kept. Today only I completed all the papers, like all of that. So geometry I'm going to give last, algebra tomorrow, and in the between of geography and algebra I'll be giving science.
Okay.
Anything you want to tell me for algebra?
As in what you want to know?
No, because we have MCQs in the first, so we have like they have given us MCQs.
Hmm.
They have said they're going to give us MCQs. So have you seen those videos which they have sent on Google Classroom?
No.
Okay,
No.
then I will forward that to you. My dad did not forward that to you.
No, there will be, I think. But I did not see.
There are a lot of videos, but I should send you only math.
You have watched it.
Videos are how to solve the paper.
Okay. So have you seen it?
No, only when I want to solve it, just before I solve it, like 2-3 hours ago, I watch it.
Okay.
So that I can remember it and solve it like that.
Okay. Those videos will be just whatever you know, you solve that first. Those sums, you solve it first and how to do it. That's it. But you have finished
Yeah, like
practicing, na? 3 chapters.
what?
You have practiced enough, right? All 3 chapters.
Yeah. Only
Oh,
arithmetic progression I'm still doing. I'm not like completely polished in. So I'm
okay.
still doing arithmetic progression.
Okay.
The
Okay.
earlier two I know how to do.
Linear and quadratic. Okay.
Yeah, because those were for my exam also, right? So that time also I had done.
Hmm. Okay. Then today do arithmetic. AP completed today itself.
Also, our school in geometry, it is doing, as I told you, Pythagoras theorem. And in algebra, see, I was not there. Okay, so I asked for 2 days. So I asked one of my friends. So they told me that they did the 5th chapter in algebra. Now I did
Probability.
not even, yeah, I did not even open it because I don't even like. I did not open it. So I do not know what chapter and what they did. And I have to do the homework also probability. So I don't know anything. So that is what they're doing in school, is what my friends told me.
5th chapter in algebra and Pythagoras
Second
theorem. Yeah.
in
Okay.
Pythagoras theorem started and they did it really fast.
Hmm. So you're attending, right? School classes also?
Only Monday, Tuesday I did not attend.
Okay.
Wednesday I attended, and from today onwards it's an holiday. Thursday, Friday till 14th.
Till 14th. Tuesday. Okay.
Oh, it's just Tuesday?
Hmm.
Like the coming Tuesday?
Next week. Next week. Tuesday. Yeah, coming Tuesday.
Oh, I was thinking that the next one. So this
I'll
is just like
finish.
the weekend.
Has she given you holiday, Renuka?
No, she's not said anything like that.
Okay.
She didn't say anything.
Then what I could do is Monday, Tuesday, Wednesday, I can take next week.
Where will you take Monday, Tuesday, Wednesday?
Same 3 to 5. Timing you
Where?
asked, no? Timing you asked, no? What you asked me?
Yeah, I asked timing only.
Yeah, 3 to 5.
But I have time till 18. Then you are saying it'll get over, right?
It will get over easily. Is she taking this Saturday?
Yeah.
She is? Okay.
Yes.
Okay, fine. Complete this sum. We'll see. We'll decide.
Yeah.
It lives on the 25th floor of a building.
Hello?
Yeah, done.
Yeah.
Okay. Can you do the third one? This is also on geometric mean only.
How to
Geometric
do
mean.
this? The other is not given. The other is
See.
not given.
So you have to find out. Now this is given, no? See, this is given.
But MR is not given.
You have to find out. You have to find out.
You should have done this one and you should have told me to do the earlier.
Okay, in this is given, no? This is given.
More work over here.
So here, segment
It's okay, I'll do it.
PM is perpendicular to QR. This is given to you, correct? So now you use a geometric mean theorem. So by geometric mean theorem, can you tell me what will be by geometric mean theorem, how it is?
Wait, I'll tell you. PM equals to square root of QM plus MR.
Into, not plus. Into MR.
Oh shit, I did plus in the earlier one. 1 second, I'm just making it. Yeah. That is why I was saying, how did I get like, okay, fine.
Show
Okay.
me your first previous calculation. previous sum
I should
calculation.
again rub and do what I did earlier.
Show me first.
I've done it with a pencil only, no problem.
No, just show me. I want to see.
Okay.
Okay, but why are you doing? No, wait. Everywhere plus you have done. Make it multiplication. 9 plus 4, make it multiplication.
Yeah, exactly.
In plus, you cannot separate the root signs like that.
Yeah, done.
So, okay.
I did
So,
plus because I just did plus. I don't know why.
substitute the values here. So this would be 10 equal to square root of QM is 8. MR you have to find out. Okay. So first what you do is take square on both sides. So this will become 10 square.
Wait, can you repeat?
Squaring both sides.
Okay.
Squaring both sides. All right. Yes, squaring both sides. So by squaring both sides, what will happen is on the right hand side, the root sign will go away. This will be 10 square is equal to 8 into MR whole square. So the square root and square goes away. So here you have 100.
So 100 equals to 8 into MR.
8
So
into
100
M.
equals to.
No, take
So
8
100
on
upon 8 into
uh,
MR.
100 upon 8 equal to MR.
What if it was 7? Then what you would have done?
Nothing.
What if it was 100 upon 7?
Same thing. No, you do the division. No, 100 divided by 7. How much
But
is
here we
100?
can divide it by 2. So that is why we can do it.
But still you'll get this. It's not divisible by 8. So you'll get decimal point. You'll get a decimal. Yeah, 100
You
is
have to
not.
go into the decimal. Or you have to just keep it like this.
No, do the decimal. You can leave it like this also, but it is always better if you write it in the decimal form.
So you
this,
don't get marks if you just leave it like this.
you will get, no, nothing like that. You will get marks, but maybe they may deduct your marks for not writing the final. Some half mark or
Why?
1 mark. 1 mark. Because they want the answer in real number, or you should not be in fractional form. It's not anything like that. You can leave it like this also. But it's better always that you write it in decimal point.
Yeah.
So 100 divided by 8 would be 2 4s are 8, 2 5s are 10, 0.
12.5.
Yeah, to 25. So half of 25, that is 12.5. Clear now?
Yeah, I'll write it. Our school was saying after Diwali there might be a test.
Semester exam. After Diwali, they're taking,
Yeah.
not before.
No.
Okay. Then I think your holidays may start early then.
I don't know. They're saying around. They were saying till last month. And then this month they said after. So then everybody was like around. So they directly went to after.
Okay, fine. We have plenty of time to
But
practice.
it's not confirmed right now. It's not at all confirmed.
Okay.
Can you hear anybody talking behind me? Like any disturbance or something?
No, no.
Okay. Hello?
Yeah, done?
Yeah.
Okay. That was the third one.
Let's do the activity
No,
after the fourth one.
for activity, we need two theorems we need. So one is a 30, 60, 90 theorem, another is a 45, 45, 90 degree theorem.
30, 60, 90 is just that the 30, like the smallest angle, opposite to that will be the smallest length. The biggest angle opposite to that will be the biggest length.
No, not exactly like that, but
In ninth, it was like that. Like 30 is the smallest. So the side opposite to 30 angle, 30 degree angle is the smallest.
yeah. So,
So that is what I was saying.
No, not smallest, but side opposite to 30 degrees, half of the hypotenuse, and the side opposite.
No, all of that we didn't have.
It was there in ninth standard. Okay, wait, I think before that we should do Pythagoras theorem.
Converse of Pythagoras. Can we do the other one?
We'll do the theorem first, Pythagoras theorem, the proof, and then we'll come to that sum there. Okay, because proof is important of Pythagoras theorem. It may be asked. They do ask the proof of Pythagoras theorem in the exam. Okay, we'll do the Pythagoras theorem first. The proof of this theorem. Okay, you know what Pythagoras theorem is, but we'll do the proof of this theorem first. And then we'll do the two properties, 30, 60, 90 degree theorem property and 45, 45, 90 degree theorem property. Then we'll come to the fourth sum. Okay.
Yeah.
So this theorem, you'll have to write the proof. Okay, first understand, I'll give you time to write it.
Our teachers don't teach it like this. Our teachers go like what is in the textbook like that. They first teach like the first chapter, like the first page and the second page, and then when the textbook comes to the practice set, then they start with the practice set. So that is a lot of time wasted. And then they make PPTs and all of that. So again, that is also time wasted.
Okay, so you know Pythagoras theorem, it says the sum of this in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides. Okay, so in this it is given.
So that I know.
Given A, B,
that is
C.
what we did in the first thing, right?
But now we are doing the proof. ABC at a angle B is 90 degree. And you have to now prove the Pythagoras theorem, that is some hypotenuse square, AC square equal to AB square plus BC square. This is now what you have to prove. Now, before starting with the proof, there is a small construction that we have to do. And the construction is you have to draw a perpendicular segment BD on side AC. That is this BD perpendicular you have to draw to the hypotenuse AC. Now, once you have done this construction, now we can start with the proof of Pythagoras theorem. That means this we have to prove this AC square is equal to AB square plus BC square. Now this line, perpendicular line, is dividing my triangle into 3 triangles. Okay, first is AD. So I'll write here in triangle ABC, BD is perpendicular to AC. This is by a construction. Okay, by construction. So you see now
I can't see you.
You can see the screen.
Yeah, screen I can see. I can see your writing also.
Okay. My video is on.
No, okay, I can see. I'm looking down.
Okay. So now 3 triangles are formed. First is triangle, the main triangle ABC. Then is triangle ADB. And then is triangle BDC. BDC. These 3 triangles are formed, and we did now first theorem, first property that I showed you. Because you are drawing this perpendicular, these 3 triangles will be what to each other? Similar.
Similar, right?
Similar. So this is similar to each other. ABC similar to ADB, ADB similar to BDC. Okay. So you will take the first two. First two will take triangle ABC similar to triangle ADB. So now since they are similar, their sides will be in proportion. So you write their corresponding sides, AB upon AD equal to BC upon DB equal to AC upon AD. Okay, so this is corresponding sides. Corresponding sides. Now from here, we'll just take the first two. AB upon AD equal to BC upon, sorry, not first two. First and the last one we'll take. Okay, first and the last. We don't require, we don't require the middle one. So AC upon AD, and number this as equation 1. Clear? Okay, wait, we'll not number this as equation 1. Do
hello.
This is AC. Sorry, I did a mistake. AC.
I don't know. 1 second. Can you go up? Can you go up?
How much are walking from 2 kilometers?
No, can you show me the figures? So first you took the figure ka ABC and then you took
ADB.
ADB. Okay. Then why did you take BDC?
We'll take in the next one. 2 cases we are
So
taking.
all okay, 2 we are taking. Okay. Yeah, fine, I do.
1 minute. I think
Hello?
I've done some mistake. 1 minute. AB upon AD, BC upon DB, and AC upon AB. Sorry, this has to be AB. I did a mistake.
How?
AB. Okay.
Oh, yeah.
First is AB upon AD, then is BC upon DB, and last AC upon AB. Okay. Now you do cross multiplication here. So AB into AB will become AB square, and this side AC into AD. This will number it as equation 1. Clear now?
Yeah, and then we just say that, oh, if you take the square root on that side, then it becomes AB square root of AC into AD.
But we'll not take the square root now. That will make our sum complicated. So if you see here, we took first, second. Now you take first and the third one. Okay, A, B, C and B,
Any
D,
two
C.
you can take.
No, not any two. First and second and first and third.
Why not second and third?
Because that we don't require. That will not give us what we want. See, ABC is the main triangle, the bigger one. So we are taking the main triangle similar to the upper one, main triangle
that's
similar to the below one that we are taking. So now let's say ABC similar to triangle BDC. So smaller one is BDC. Since they are similar, their corresponding sides will be in proportion. So you have AB upon BD equal to BC upon DC equal to AC upon BC. Okay, this is corresponding sides. The corresponding sides. So from here we require first and the last, no, second and third one will require. So we'll just take that BC upon DC is equal to AC upon BC. Do cross multiplication here like this. So here you have BC into BC, that will be BC square. And on the right hand side will be AC into DC. This you number it as equation 2. Now you see you have equation 1 and equation 2. So equation 1 and 2, you add them. You add equation 1 and
Wait, hello, how did you add?
equation 2. When you're adding, you add right hand side with right hand side, left hand side with left hand side.
No, but how? Under what formula? Under what?
What?
Functions are you adding?
No, I can't hear you. What you're saying?
Under what formula? Under what are you adding?
That's what I'm saying. You add right hand side with the right hand side and you add left hand side with the left hand side. So you see.
No, but why? Like, okay, fine.
First equation is AB square is equal to AD into AC. And second equation is BC square is equal to AC into DC. So you add them. So add right hand side with right hand side. So this will become, sorry, left hand side with left hand side. So this becomes AB square plus BC square equal to right hand side both add AD into AC plus AC into DC. Is this clear?
Yes, and then you do AC cancel, and then you do
No,
AB.
I can't understand what you're talking. It's very,
And then you do AC cancel.
take AC common. So when you
No,
take,
then you do AC cancel.
no, it will not get cancelled. Take common outside. So when you take AC common outside, you have AD plus DC. Now, if you look in the figure, AD plus DC is nothing but AC. Okay, AD plus DC is equal to AC. So here you substitute in place of this, substitute AC. So you have AC into AC, which is AC square. Understood?
Yeah.
So this is what we need.
Square plus BC square equals to AC. Oh.
So this is how we get AB square plus BC square is equal to AC square, which is your Pythagoras theorem. You can say hence proved. Now I know it is there written in your textbook, but I want you to write it now, entire, right from start to end.
So this is asked for how many marks? 10.
Theorem 3 marks.
So much for 3 marks?
Yes, theorem 3 marks.
This should be for 10 marks.
If you see in your textbook, it is very small.
Okay, actually,
It's written very small.
So here how you wrote so big?
Because I have done indeed. They have written side by side. I have written one below the other.
Okay.
3
Only
marks.
boxes.
Yeah, 3 marks, or it can come as an activity. Fill in the boxes.
Oh,
Okay, I want you to write
okay, I
it
will write it
right,
down.
right now with the proof, entire proof.
Diagram.
Understand and write. You don't understand any step anyway, you can ask me.
This is for the what is this?
Pythagoras
Theorem
theorem. Pythagoras theorem.
Python. Okay. Hello? Hello?
Yeah, finished?
Yeah, done.
Okay. So now next we'll,
Are we going to write anything?
what? Are we?
Are we going to write anything? Because I wrote so much now, I don't feel like writing.
Yeah, actually, yes, we'll be writing. Because we have to do two properties and I want you to write those two properties. So in that, the first property is a 30, 60, 90-degree theorem. Okay. So what this theorem says, you can take a screenshot and write later. So what this theorem says is that if you have a right angle triangle, okay, a right angle triangle, one is 90 degree angle B, one
So,
angle,
no, so
what?
this is not 30, this is 30, no? This one is 30.
Yeah,
Smaller is 30.
anything can be 30. At least in the diagram, you can show anything 30. So, okay, we'll take this 30 and this 60. Then what this theorem says that side opposite to 30 degree is half of hypotenuse. Okay, so if you see in this side opposite to 30 degrees AB, so AB is half of hypotenuse AC. And side opposite to 60 degree. The side opposite to 60 degree is √3 upon 2 times the hypotenuse.
Why
Okay,
so much of confusion, √3 upon and all of that? Why not just take 2 times, 3 times?
for 45, 45, 90, it will be easy. Only for 30, 60, 30, 60, you have to remember. So side opposite to 60 degrees BC. So BC is √3 upon 2 times hypotenuse, that is AC. These are the two very, very important things, important property that you have to keep in mind. Okay, side opposite to 30 degrees, half of the hypotenuse. Side opposite to 60 degrees, √3 upon 2 times the hypotenuse. Have you understood this? Yes or no?
Yeah.
Okay.
I should write this down?
Yes.
Okay.
We have one more to write, 45, 45, 90. That is also easy, it's very simple.
Everything is easy.
Actually, they have deleted very much and have kept all the easy part. So you should take advantage of it. And geometry is easy. It's very easy. Compared to science, I find maths is easy.
Okay.
And you can score full 100 on 100 in math.
No, the math thing which I'm giving is only for 40 marks. Now it's 40 marks, next will be 80, and then after 80, all the three left will be 100.
No, the internal that they take is then 20 marks. 40 algebra, 40 geometry.
No, SSC does not take. Balmohan does not take internal.
There is 40 marks algebra, 40 marks geometry, 20 mark algebra.
Yeah, so that is like the term exam. What is the internal?
Unit test.
Yeah, so unit test, yeah.
No, I am talking about your final board exam. 40 marks algebra, 40 marks geometry, 20 marks of algebra, 20 marks geometry, the school sends. Your school should give you full 20 on 20 in algebra, 20 in geometry. Now that how it's sent at the school, they take the unit test marks or they take the what marks? Usually unit test
No,
marks.
we have assessments. 5 marks for classwork and 10 marks for the homework, like the one assignment they give. Like in science, we have given the assignment to
15.
find about in Yeah, total 15. 5 is for classwork. You have to keep your classwork complete, and it should be in legible handwriting.
Notebook
And
and notebook.
yeah, classwork book. Yeah, notebook. Notebook.
So,
And
so
the rest 10 marks are for the ones that they give. Like they give us sometimes, like some teacher has given us 4 MCQs and 6 marks for assignment, like research on this, research on that. So some people just do copy paste, so they don't get full 6 on 6. The ones who like research and then write a summary, those people get 6 out of 6.
okay.
Because MCQs are easy. MCQ 4 marks everybody gets, but 6 marks not everyone gets.
Okay. So usually something around like that. They take the 5 marks assignment, 5 marks notebook, and 10 mark whatever MCQ and all, however they give.
Okay. One
It's
second, I'm
different.
writing.
Yeah, right.
Though it's a now they have like kept it like this. Till ninth we did not have all of this. So 10th only they have started this, that like now in English I had one thing, 5 marks for my classwork book. Okay, and then 5 marks for one assignment which she told us to find about N.E. Subramanian or somebody. English, he was a poet or an author that I don't know. I still have to do that. So there is no deadline to this, but there is just like who does it better, who does it like a better paragraph, who writes better, who has better English skills and all of that. So those people, and then 4 MCQs. Some teachers keep 4, some teachers keep 5.
Okay. So it depends on the teacher then.
Yeah, finally 15 marks they have to give, right? So anyhow they want, they can give. Done.
Okay.
Hello?
Next we'll do 45, 45, 90-degree theorem. So second is 45 degree, 45 degree, 90, 45, 45, 90 theorem. So what this theorem says that, what this theorem says, in a right angle triangle, okay, name the same thing, A, B, C. So if this is 90, if this is 45, then this also will be 45. Okay, so 45, 45, 90. That means two angles are 45, one is 90 degree. So what this theorem says, side opposite to 45 degree, side opposite to 45 degree is 1 upon root 2 times the hypotenuse. Okay, 1 upon root 2 times the
Which
hypotenuse.
45?
Both. So side opposite to this 45 is BC, and side opposite to this 45 is AB. So BC and AB both are equal to 1 upon root 2 times the hypotenuse, that is AC. Both of them. That means both of them will be of the same length. Okay, both of them will be of the same length. Is this clear? Yeah, right.
Only one is there in this?
What?
Only one is there in this?
No, actually there are two sides, but both of them will be equal.
No. Only one formula is there in this.
Yes, yes. Because 45, 45, that's the same matter. That is.
Okay, then wait. Hello? Hello?
Done?
Yeah.
Okay, now we can come to the exercise.
How many sums are of this using these formulas? How many?
4, 5, 6, 4, 5, and 6.
I'll just share my screen.
So now we can do the fourth sum of your practice set.
All the sums are going to do.
Yes.
Okay.
What happened? Any problem?
No, I just said okay.
Okay. So this chapter has, I think, only 3 exercises, and the next this application is deleted. So here it is less portion we have here. Let's see. Two 2.2 is not done. Huh? 2.2 is not the exercise.
I don't know. I will have to see.
Yeah,
Just give
2.2
me
is.
1 minute.
Then we have directly the problem set.
Converse is there. Pythagoras theorem.
Practice. See for practice at 2.2. It's not there. It's deleted.
Application of Pythagoras theorem and Apollonius theorem. Practice set 2.2 is not there. Only 2 are there. You're saying 3?
No, I thought the third is actually problem set. I thought that is an exercise. So we have problem set.
Yeah, and from problem set also, from problem set also, exercise 1, question 6, and then next page 8, 9, 12, and then next page 17, 18.
Yeah, that when we are doing, we'll do that. We'll complete this sum. This is easy. Now, if you see here, this is 90 degree, this is 30 degree given, and obviously this last one, remaining one, will be 60 degree. Okay, so this is a 30, 60, 90 degree theorem, triangle. They are asking you to find out what is the find RP, that is this length you have to find out, and find PS, that is this length you have to find out. Okay, so here we will use a 30, 60, 90 degree theorem. So by 30, 60, 90 degree theorem, side opposite to 30 degree. Which is a side opposite to 30 degree? Can you tell me? Look in the figure and tell me.
SR.
So SR, and the theorem says side opposite to 30 degrees half of hypotenuse. Hypotenuse is RP. Okay, but in this case SR is given, so that is 6 is given. 6 is equal to half into RP. Take this 2 that side, it will get multiplied. So 6 into 2 is equal to RP. So this becomes RP is
equals to
equal
12.
12. So we have got this. But we have to find out one more. No, we have to find out PS also. So here we'll see side opposite to 60 degree. Which is the side opposite to 60 degree? Can you tell me?
SP.
Yes, side opposite to 60 degree, and the formula says that is root 3 upon 2 times the hypotenuse, that is RP. RP we just now found out, so we'll substitute
12.
the value. So into
SP
12.
we don't know.
We are finding out, no SP. They have asked us to find out.
Okay.
So
Yeah.
2 ones are 2, 6 are 12. So SP is 6 root 3. That's it. This is what we had to find out. Here I'll write.
Done?
Did you understand?
Yeah.
Okay. So here we have used the side opposite to 30 degree formula. It is half of the hypotenuse. Here we have used side opposite to 60 degree, which is root 3 upon 2 times the hypotenuse. Now write it down.
And by the way, our geometry teacher has already done chapter 4. Remember during the exam I told you she had started.
Constructions. No?
Yeah, and then
Yeah.
she completed also.
Okay, yeah, we have time for construction.
Hello.
Yeah,
Hello.
done.
Yeah. Now the fifth one.
Yeah, activity. This activity is based on 45, 45, 90-degree theorem. Okay. So now we know side opposite to 45. Now in this, for finding AB and BC with the help of the
Hello.
information, yeah.
Could not hear me. I was asking you in the textbook only.
Yeah. Yeah. So in this, length of the hypotenuse AC is given as root of 8. Okay, and AB is equal to BC is given to you. Okay, if you see in the question, this and this, AB is equal to BC, there are two lines on that. That means they are equal. So here you write given. Angle BAC. Now what will be BAC? Now since these two angles are equal to each other, these two sides are equal to each other. So this becomes an
45.
isosceles. Yeah. This becomes an isosceles right angle triangle, and an isosceles right angle triangle, they will be 45 degree. So this is 45 and this is also 45. And you know, side opposite to 45 degree is what? Side opposite to 45
1
degree is,
upon root 2, na?
so here you write 1 upon root 2 times the hypotenuse. So again here also you write the same thing, 1 upon root 2. Now here also you write same thing, 1 upon root 2. Root 8 is written as 2 root 2. Now this root 2 and root 2 gets cancelled and you are left with just 2. So 2 is, yeah. Now let's do the sixth one. Sixth one is also very simple. It's very easy. You have to find the side and the perimeter of a square.
Where is this question?
Sixth one.
Figure 2.21. Acha, no, there is. Okay, okay. No, I
So
directly went to 7.
you have to find the side of a square and the perimeter of the square whose diagonal is, the length of the diagonal is given. Diagonal is 10 centimeters. So I'll just name this square A, B, C, D. Okay. Now, one thing you know about a square here, all angles are 90 degrees. So this becomes right angle triangle. So now if this is 90, how much will be this? Can you tell me?
45.
Yes, it will be 45. So this
But
is
it can
40.
be 60-30
No,
also.
no. It cannot be 60. It definitely cannot be 60 because what are all the angles in a square?
90.
90. That means this is 90, right? Full. This is 90. And this here is half of 90.
Oh yeah, okay.
That's so
And
it is
also
40.
all the sides are equal, so
Yes.
the sides are also equal.
So this is equal to this. So we can use 45, 45, 90 degree theorem. So what that says, side opposite to 45 degree is which is the side opposite to 45 degree here?
Which 45? Any 45, I'll tell you.
Yes,
Okay, then opposite to A is BC.
BC. Okay. Whatever is BC, that will be equal to AB. So that is 1 upon root 2 times the hypotenuse. Hypotenuse is AC.
Yeah.
Length of the hypotenuse is also given. It is 10.
What about BC?
So BC is equal to, you can say 10 upon root 2. Now this you can reduce. Okay, this you can
How?
reduce. 10, you can write it as 2 into 5 upon root 2. Now one thing you know that root 2, what is root 2 into root 2?
2.
2. So this 2 here, we replace it with root 2 multiplied by root 2. And this 5 as it is, and this root 2 as it is. Now this root 2 and root 2 gets cancelled, and you are left with BC is equal to 5 root 2.
Instead of that, why didn't we do that? We made this root 2 into 2, and then we cancelled 2 and 2, and then we kept 5.
No, here only one root 2 is there. No? Root 2 multiplied by root 2 is 2.
No. Why didn't we just make this 2? Why didn't we just make this 2? So then it becomes 2 into 5 upon 2. So you just cancel 2, 2, and then 5 is left.
No, you cannot do that. Root 2 multiplied by root 2 is 2. Getting it? Root 2, here there is just one root 2. This you cannot replace. This you can replace. 2 as
No, but
written.
2 you can make root 2, but then root 2 you can't make 2.
No, you can't make, no? Because root 2 square is 2. So this 2 I have replaced, not root 2. Got it?
No.
This root 2, you cannot replace it with anything. Why you want to replace root 2?
So that it's easier and we get a easier answer.
You are saying replace root 2 with 2.
Yeah.
No, root 2 is not equal to 2. No? You are saying root 2 is equal to 2. No, it is not equal.
Then
If you
what is
want,
root 2 equal to?
what is the value of root 2? Root 2 is 1.41 something, no?
No, but root 2 is
Say?
no, but root 2 is like 2 into 2. Root 2 is like root 4. Root 4 is root 4 into root 4, right?
Root 4 is 2.
Yeah, but
Square root of 4 is 2.
no, there was something. Root 2 is root 2 into root 2, which is then root 4, and then it is 2. So root 2
Yeah.
is equal to 2.
Yeah. Root 2 into root 2 is root 4, and root 4 is equal to 2. So that same thing we use, no? Root 2 into root 2 is equal to 2. So 2 you replace, not root 2.
So you cannot do root 2.
No, you cannot do for root 2. See, this is replaced like this. Getting it?
Oh,
Right. We still have to find the perimeter of the square. Do you remember what is the formula for perimeter of a square? Yes. Do you remember the
no.
formula? 4 into side.
Oh,
4,
yeah.
4 into side. So
How do you
4,
remember? So?
4. Perimeter is just you add all the sides. No?
Yeah,
And,
but to remember that, I don't know, remember that now.
and the side is 5 root 2. So 4 into 5 becomes 20. So the answer is 20 root 2. The perimeter is 20 root 2. Write down the formula.
Done.
Okay, I want you to do the 7th one right now. In the 7th one, I'll give you a hint. You have to use geometric mean formula. So in this one,
Geometric mean method.
F FG is given 12, GD is given 8. You have to find out EG,
Yeah, got it.
find out FD and EF. So first find out EG.
Oh, I have to find DF and EF also.
Yes. So that will get by Pythagoras theorem.
Baapre. So first you do this theorem, then you go to Pythagoras theorem.
Yes. So first find out EG. We'll go step by step. First use geometric mean theorem and find out EG and show me.
What was the theorem? Yeah,
Geometric.
yeah, got it. Is it okay if I don't draw the diagram like how it is shown? Thoda sa if I'm
Have
drawing
you
it by hand.
How you'll draw? Okay.
No, I'm not drawing it with a scale. That's the only difference.
Okay, yeah. No problem.
I've got 12 equals to root 8 into GE, so I should not like, first I should separate the root.
No, not try to take square first. What you got? You said you got 12 equal to
12 equals to
Hmm.
root 8 into GE.
Then you take square both sides. Now square it both sides. So you'll get 144 is equal to 8 into GE or EG, whatever it is. Now you take 8 and divide it. 144 divided by 8 equal to GE. Getting it? You understand this?
Yeah.
How much is 144 divided by 8?
What else do I have to find now?
How much you got EG?
18.
18. The EG is 18. So that means this ED is 18 plus 8, that is 26. Now you have to find out FD and EF.
Yeah.
There you will have to use Pythagoras theorem. So here also use Pythagoras, for FD also use Pythagoras theorem, but use a smaller triangle. This FDG. Okay, in triangle FDG. Okay, use Pythagoras theorem.
No, if I use the Pythagoras theorem for EDF, then I get it for all. No, so once only I'll use Pythagoras theorem.
No. If you use it for
Why
EDF,
not?
you will not have length of DF, nor you have length of EF.
No. EDF.
EDF, no, so bigger one, na? EDF.
Yeah, biggest.
So if you use EDF, side 1 is DF, side 2 is EF. You don't know length of any of those.
Oh, so then what?
So use a smaller one, na? Use FDG, this one.
Or I can also use EGF.
Yes. So when you use FDG, you will get FD, and when you use EGF, you'll get length of EF. So both you have to do. Understood what you have to do?
Yeah.
First, tell me what is FD. Fast, come on.
80. DF square equals to 80. So DF equals to?
Wait, let me check.
What is the square root of 80?
Have you got 80?
A square minus 12 square.
No, by subtracting in that smaller triangle. Okay, in the smaller triangle, FD is a hypotenuse. See now, this is 90 degree here, so FD becomes hypotenuse. So FD square equal to.
No, but the hypotenuse is also on F. I took it like that.
Hypotenuse
F
is
is
on.
also 90 degree. 90 degree is F.
90 degree at F is for the bigger triangle. Pay attention properly. See properly what you're doing.
Wait, what?
For F, the 90 degrees for the bigger triangle. I'm telling you to look at the smaller triangle. Pay attention to the sum. How can you just do without carefully reading and looking at the question?
Okay.
See, look at the triangle like this.
Yeah, got it.
So FD becomes a hypotenuse. So FD square equal to
GD square plus GF square.
GD square plus GF square. FD you have to find out. GD is 8. So 8 square plus 12 square, which is 64 plus 144. That is 8, 208. So FD square is 208. So you have to take the square root of 208. So do this by the prime factors method. 2 1s are 2, 0, 2 4s are 8. 2 5s are 10, 2 2s are 4. 2 2s are 4, 2 6 are 12. 2 1s are 2, 2 3s are 6, and then you can just write 13 1s are 13 because 13 is a prime number. So from here you have 2, from here you have 2. So this becomes, multiply them and single what is there that you write inside the root. It becomes 4 root 13. Did you understand this?
Yeah. Why
Right.
don't they give a proper this? No,
Proper what?
I'm done right.
Proper
Why
what?
don't they write a proper? Why don't they give a proper side in the final, like when you
Because they
find out everything?
because they want to increase the calculation.
Okay. So again, Pythagoras. 1 second.
Now again same thing. Now this was how much we got. EG how much we got? 18. EG was 18. So now you use Pythagoras theorem in this triangle here to find length of EF.
Yeah, 1 second. EF square is 468.
And you have to take square root now. EF square is 468. Now take square root of 468. Do prime factor method. 2. Can you do this? Do the prime factor method and tell me. Remember, no?
Stopping at 117. Stopping at 117.
Stopping at 117.
Stopping in the sense I'm getting stuck at 117. First you say 2, then
Tell me 2. What
2,
you got?
3, 4.
Then next.
Then 2 ones are 2, and then 2 ones are 2 again, is the 1 is left 7.
Okay, now do
And then
3.
what after?
3. 3 threes
Oh,
are
we
9.
can also do 2 5s are 10,
No,
and then
it-
1 is.
No, this is
Oh,
7.
no,
No, no. Do by 3, you will get it. 3 threes are 9. And here 2 will be. So 3 9s are 27. Again, do by 3. 3 1s are 3. 3 threes are 9. Now 13 is a prime number. So directly 13 1s are 13.
Two into 3, 6.
Hmm.
6 root 13.
Correct. 6 root 13. Then you finish writing?
Yeah.
That was the 7th one. Okay, we'll stop here. So we have 3, 8, 9, and 10 remaining. Okay, 8th one, 9th one, and 10th one is remaining. 8th one I want you to do for homework because it is same like the 6th one. 8th one, same like 6th one.
Till when? Sunday.
Today itself.
Today I have a class, and then.
After the class, there is plenty of time, just one sum.
Okay.
And also you see that you revise. Today what we did, revise before you, after your class.
Yeah.
Okay. See that you revise it.
Yes.
What class you have now at 5?
I have an SS class and social science.
Up to?
Tuesday, Thursday.
Till what time?
5:15 to 6:15.
Okay, then after that you are free anyways. So this sum,
Yeah.
and today we did how many sums we did today? 1, 2, 3, 4, 5,
Oh,
6.
after that also I have. Okay, fine.
5
I can
sums.
submit it by tomorrow.
No,
Because I
today
have
itself.
school homework also.
I know, I want it today itself. It's just 1 hour. Today itself, anytime
Oh,
before you
what?
sleep, before
Just
10
one
o'clock,
sum?
11 o'clock. No, all 6 sums that we did today along with the proof. I want you to practice today itself and send it to me.
Okay, then
Okay.
can I send it to you by. Yeah. I'll do it today only, but I'll send it to you by late night, like 10 or something like that.
Chalega. Will do.
6 sums
Today.
I have to do.
Yes, 6 sums and the theorem. Which theorem? Pythagoras theorem proof.
Proof.
I'll send it right.
Okay.
Just don't write this statement. I want the proof also. Practice it.
Yeah.
Okay, I'll send it.
Back from a search.
I'll send it in the WhatsApp in the group. Okay.
Yeah. Okay.
So tomorrow 3 o'clock.
Yeah. Okay.